Welcome to This Explainer. Today, we're going to completely decode the execution process behind massive oil and gas projects. We'll break the whole thing down, step by step, in simple language. Seriously, have you ever wondered how a simple idea on a piece of paper transforms into a sprawling, multi-billion-dollar facility? The kind with thousands of workers and incredibly complex equipment? Well, it is a truly monumental undertaking, and it goes through some highly rigorous stages before a single drop of product is ever actually produced. We're going to cover this in 5 main phases. First, concept and detailed design. Then, the procurement and construction phase. Third, controlling the mega project. Fourth, testing, commissioning, and startup. And finally, handover to the client. All right, let's jump straight into phase 1, concept and detailed design. So everything starts when a client identifies a need, right? Maybe it's a new refinery unit, a gas processing plant, or a storage terminal. But before any real design work kicks off, they have to run a rigorous feasibility study. They need to know if this is actually technically and financially viable. They're looking at the total project cost, the required capacity, location, environmental constraints, and, of course, the expected benefits. If and only if all of that checks out, they finally move forward with project approval. Now, a really crucial step here is what's called FEED, or front-end engineering design. This is exactly where engineers define the basic process and the major requirements of the plant. We're talking process flow diagrams, preliminary layouts, initial cost estimates. Basically, this gives the entire project team a unified, crystal-clear understanding of what actually needs to be constructed. And taking that into detailed engineering, man, it requires a staggering level of coordination. You've got totally diverse disciplines working together concurrently. Process, civil, mechanical, piping, electrical, instrumentation, and structural engineers are all in the mix. They're generating everything from piping layouts and equipment schematics to foundation plans and cable schedules. These documents literally become the absolute baseline for all of the construction. Okay, moving on to phase 2, procurement and construction phase. Now we hit procurement, which involves managing a truly global supply chain. The team has to identify all the needed materials, pumps, vessels, massive valves, and then issue requests for quotation to evaluate them both technically and commercially. After the purchase orders are issued, they have to actively oversee the manufacturing process and quality inspections before any of this massive equipment is finally shipped out to the site. And since this large-scale equipment can take months to manufacture, meticulous procurement planning is absolutely vital. I mean, think about it. A delay in just one piece of critical equipment, like a specialized compressor, could literally bring the entire construction schedule to a grinding halt. So once those materials start arriving, the civil works kick off to lay the literal groundwork. You'll see massive earth-moving operations for excavation, followed by pouring plain cement concrete, tying tons of reinforcement bars, setting up formwork, and eventually pouring the deep, heavy foundations that are going to support thousands of tons of steel. Right on the heels of the civil works, multiple disciplines start working simultaneously to install the massive equipment, run kilometers of piping, and set up highly complex electrical systems. It's like a heavily choreographed dance. You've got cranes lifting heavy vessels, welders joining pipes, and electricians laying down vast cable networks. All of these activities have to be perfectly timed to ensure both safety and efficiency on what is usually a very, very crowded site. Which brings us to phase 3, controlling the mega project. Behind all of that physical chaos on the ground, you have the planning and project controls team. They prepare incredibly detailed schedules. Using specialized tools like Primavera P6 or MS Project, they track thousands of individual activities. They monitor milestones, manpower, and overall progress, so they understand exactly how a delay in one task impacts the next by mapping out the project's critical path. By constantly comparing what was planned against what is actually happening on site, the team can spot delays early and immediately develop a recovery plan. Honestly, this rigorous daily, weekly, and monthly tracking is the only way a project of this massive magnitude actually stays controlled and on budget. Now for the most exciting part, phase 4. Testing, commissioning, and startup. At this stage, every single system is rigorously inspected, pressure tested, and calibrated to ensure flawless installation. They will push water or air through the piping systems at extremely high pressures to check for leaks. They verify the electrical logic and ensure every single valve turns exactly when the control room tells it to. Any minor defects, what the industry calls punch points, are systematically logged and resolved. The absolute most crucial objective here is making certain that this massive facility poses zero danger before it's energized with actual hydrocarbons or high voltage power. The plant just has to be totally safe, complete, and perfectly ready. During commissioning, the systems are finally energized and started up according to strictly approved procedures. They're tested against required specifications and then transitioned toward normal operations. It's a very careful, phased approach. They bring units online one by one, verifying process parameters like temperatures and pressures until the entire plant is humming along seamlessly as a single integrated machine. Finally, we reach Phase 5, handover to the clients. The contractor officially closes out the project by submitting a mountain of critical documents to the client for ongoing operation and maintenance. These are essentially the blueprints and user manuals for a multi-billion-dollar machine. It guarantees the client has absolutely everything they need, from the final as-built drawings to the test certificates and commissioning documents, to run the facility safely for decades to come. So, looking back at the macro journey, we've gone from a simple concept to highly detailed engineering. We navigated a global procurement web, powered through a massively complex construction phase, executed careful commissioning, and finally reached the handover. Behind every successful facility is an absolute army of specialists working in perfect unison: engineering, procurement, construction, planning, safety, and the client. So does knowing this staggering level of coordination change how you view the colossal industrial infrastructure all around us? Next time you turn on a light or fill up your car, maybe think about the years of intense engineering it took to make it happen. Thanks for joining me for this explainer, and keep questioning how our modern world is built.